Last chapter we have seen the objectives and functions of operating system. Today we'll see the types of operating system. Operating systems are there from the very first computer generations and they have kept changing with time. You have seen the computer generations in the first year. So today we'll start with the different types of operating systems. The first is batch operating system. Early computers were physically large machines run from a console. Console means a separate input device. The common input devices were card readers and tape drives. The common output devices were line printers, tape drives and card punches. The users of such system did not interact directly with the computer system. The users prepared a job which consisted of the program, the data and some control information about the nature of the job and submitted it to the computer operator. The job would usually be in the form of punch cards. At some later time, the output appeared. The output consisted of the result of the program. The operating system in these early computers was fairly simple. Its major task was to transfer control automatically from one job to the next. To speed up processing jobs with similar needs were batched together and were run through the computer as a group. Thus, the programmers would leave their programs with the operator. The operator would sort programs into batches with similar requirements, and as the computer became available, would run each batch. The operating system from each job would be sent back to the appropriate programmer. A batch operating system normally reads a stream of separate jobs, each with its own control cards that predefine what the job does. When the job is complete, its output is usually printed. The feature of a batch system is the lack of interaction between the user and the job while that job is being executed. In this execution environment, the CPU is often idle. This idleness occurs because the speeds of the mechanical input-output devices are slower than those of electronic devices. So as you can see in the diagram, the users give their programs and data on punch cards to the operator. These are known as jobs. So the jobs with similar requirements, that is, for example, some users want to execute C programs, some users want to execute C++ programs. So all the C programs will be brought together and it will be created as one batch. All the C++ programs will be brought together and it will be created as the second batch. The operator will give the first batch of C programs to the computer to execute. The computer will execute and give the outputs on the printouts. Then the operator will remove this first batch from the computer and then will feed the second batch, that is of C++ programs, to the computers. The computers will then execute these programs and give the printouts. This operator will then collect all the printouts and distribute it back to the users. So as you can see in the diagram, there is no interaction between the user and the computer system. The user will give the programs to the operator and the operator will feed the programs to the computer and then will give back the printouts. So in the second diagram you can see that the operator is feeding the data to the computer system with card readers, and the computer system will execute these programs and give the output on line printers. So in this case, the input device, that is the card reader, and the output device, that is the printer, the speed of these two mechanical devices is very slow. So till the operator feeds the card reader, the CPU is idle. Till we get the output onto the printer, again the CPU is idle. So there are these two problems with the batch operating systems. Next, if you want more information on batch operating systems, you can watch this video. Next we'll move on to the second type of operating system, that is multitasking operating system. As you can know on the name itself, multitasking means doing more than one task at the same time. Multitasking is when multiple jobs are executed by the CPU simultaneously by switching between them. Switches occur so frequently that the users may interact with each program while it is running. So this is the main advantage of multitasking operating system. In batch operating system, the user could not interact with the computer. But in multitasking operating system, the users can interact with each program. An operating system does the following activities related to multitasking. The user gives instructions to the operating system or to a program directly and receives an immediate response. The operating system handles multitasking in the way that it can handle multiple operations, executes multiple programs at a time. As the system switches CPU rapidly from one user to another, each user is given the impression that he or she has its own CPU, whereas actually one CPU is being shared among many users. So as you can see in the diagram, one user may be using Microsoft Word, a second user may be sending an email, a third user may be surfing web browser. All these three tasks are collected by the operating system, but the CPU will execute only one task at a time. But it will switch, that is move on the processes so fast that the users will think that he is using the CPU. In the second diagram you can see that there are 4 processes, but remember that the CPU can execute only one process at a time. The operating system will switch from the browser to the Excel, from Excel to the Paint, from the Paint to the media player so fast that the user will think that all the 4 tasks are being executed at the same time. Next we'll move on to the third type of operating system, that is multi-programming operating system. As the name implies, multi-programming operating system means running more than one programs at a time. Sharing the processor when 2 or more programs reside in memory at the same time is referred as multi-programming. Multi-programming assumes a single shared processor. Multi-programming increases CPU utilization by organizing jobs so that the CPU always has one to execute. The main goal of multi-programming is to increase the CPU utilization. For more information on multi-programming, you can go through this video. Next we'll move on to the fourth type of operating system, that is time sharing operating system. As the name implies, time sharing means we are going to share the CPU time to different users. Now let's see this diagram. At the center you have the CPU, which is shown as a watch. The CPU time has been distributed into 6 different intervals, time intervals. These time intervals are in microseconds or seconds. These time intervals are also known as time quantums. So in the given diagram you can see that the CPU time has been divided into 6 different time quantums. So the first time quantum will be given to user 1. The CPU can execute the user 1's processes for a given time quantum. When the time quantum is over, the CPU will release the user 1 processes and the next time quantum will be allocated to user 2. Similarly, the user 2 will execute its processes for a given time quantum. When its time quantum expires, the CPU will release the user 2 processes. And the same procedure will go on for the remaining 4 users. When the user 6 finishes with its time quantum, the next time slice of the time quantum will be given to user 1. If the user 1 does not have any processes to execute, it will be given to user 2 and so on till all the users finish with its processes. So it is similarly like cutting a round cake into equal slices for all the friends. Time sharing or multitasking is a logical extension of multiprogramming. Processor's time, which is shared among multiple users simultaneously, is termed as time sharing. Now, what are the advantages of time sharing operating systems? First, it provides the advantage of quick response. Since one time slice is given to only one user, the user can interact with the system and get a quick response. It reduces the CPU idle time. As the CPU time has been divided to different users, CPU will not remain idle. For more information on time sharing operating systems, you can go through this video. Next, we'll move on to the fifth type of operating system, that is distributed operating system. As the name suggests, the distributed operating system will refer to where the load of processing is being distributed into different computers. So as you can see in the diagram, there are 5 different computers with having its own CPU, memory and disk. These 5 different computers are known as nodes or sites. These nodes or sites may be in the same building, that is in the same location, or they can be far away. If they are in the same building or very close to each other, they may be connected through wires. If they are far away or at different location, they will be connected through internet. Distributed systems use multiple central processors to serve multiple real-time applications and multiple users. Data processing jobs are distributed among the processors accordingly. The processors communicate with one another through various communication lines. With resource sharing facility, a user at one site may be able to use the resources available at another. So the main goal of networking, that is resource sharing, can be done by using the distributed operating system. So a user at one site can send its process to another site to use its resources for execution. Speed up the exchange of data with one another through electronic mail. So if you want to send information from one processor or one site to another site, we can send it through emails. If one site fails in a distributed system, the remaining sites can potentially continue operating system. So in the previous diagram, there are 5 sites or 5 processors. If one processor fails, the remaining 4 sites can go on with its processing. So the system will never come down. Better service to the customers. Due to the previous point, that is if one site fails, the remaining sites can continue operating. This we can give the better service to the customers. Reduction of the load on the host machine. So there is not only one single machine who is being executing. So there are different nodes. The load of the programming or the execution can be distributed to the different sites. For more information on distributed operating system, you can go through this video. Last, we'll move on to the last type of operating system, that is real-time operating system. As the name implies, you can understand that this operating system should work in a given time. A real-time system is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. Real-time systems are used when there are rigid time requirements on the operation of a processor or the flow of data, and real-time systems can be used as a control device in a dedicated application. A real-time system is a time-bound system which has well-defined fixed time constraints. Processing must be done within the defined time constraints or the system will fail. The examples of real-time operating system are scientific experiments, medical imaging systems, industrial control systems, weapon systems, robots, air traffic control systems. There are 2 types of real-time operating systems. First is hard real-time systems. Hard real-time systems guarantee that critical tasks complete on time. The deadline is handled very strictly, which means that given task must start executing on specified scheduled time and must be completed within the assigned time duration. For example, medical critical care system or aircraft system. So for example, if a patient is on a ventilator and its oxygen level is being going down, this operating system will tell that the oxygen is going down and you should start with the oxygen. So it should act in a given time. If there is some late or delay in the execution, the patient may go in more critical condition. So in hard real-time systems, the operating systems, the programs of the operating system should work so fast that it should be executed in a given time limit. The second real-time operating system is soft real-time systems. Soft real-time systems are less restrictive. In this, there is a deadline assigned for a specific job, but a delay for a small amount of time is acceptable. For example, online transaction system, multimedia, virtual reality, advanced scientific projects like undersea exploration and planetary rovers. So in this case, if there is some time delay in the execution, and because of this there may be no loss to the life. But in hard real-time systems, if there is a delay in working, there can be some loss to the system. So we finish with types of operating system. Thank you.